This is a solution to problem number 20 from chapter 6, Work and Energy, from the textbook that you see here. So here we have a baseball that is being caught. It's initially traveling at 32 meters per second, and of course it comes to rest, and in doing so it moves the fielder's glove backward 25 centimeters. And we want to determine the average force exerted by the ball on the glove. So we're going to actually calculate the force exerted by the glove on the ball, and then using Newton's third law, we obviously would then reverse that and then find the force exerted by the ball on the glove. Okay, so basically the ball comes in and is caught by the glove. So it's coming in with an initial velocity of 32 meters per second, and it travels a distance of 25 centimeters. So delta x is 25 centimeters before coming to rest, and here the final velocity is simply 0. So if we zoom in on the ball itself, and what we'll notice is that there's only one force that's acting on the ball, and that is the force exerted by the glove on the ball, and that is the force that's actually doing negative work and actually stopping the ball. So if we look at the net work done, okay, so the net work done is simply equal to the force FGB, that's the force exerted by the glove on the ball, multiplied by delta x. Remember, it travels delta x, and of course the angle between the FGB and delta x is 180 degrees, so that's cosine 180. And when you compute all of that, we simply get FGB multiplied by 25 times 10 to the power minus 2, converting centimeters to meters, and of course cosine 180 is negative 1. Okay, so we'll just leave that there for now. Just box it up. I'm going to come back to that shortly. So we basically need to chase down more expressions and equate. So we also know that the net work done is equal to the change in the kinetic energy, which is simply equal to a half times mass times final velocity squared minus half times the mass times the initial velocity squared. So when we start to plug in the values, what do we get? Well, we get W net is simply equal to half times the mass. Remember, the final velocity is going to be 0, so in fact we could actually just ignore this altogether. So this is simply half times, let's just put it in, 0,145 multiplied by 0 squared minus a half times 0,145. Of course, we're using the kilograms, we converted the mass to kilograms, multiplied by the initial velocity, which is simply 32 squared. Okay, so basically what we end up with is an expression that W net is equal to minus a half times 0,145 multiplied by 32 squared. And we'll continue on the next slide. Okay, I've just tidied up the expression before moving on. So we have two expressions for W net, which we just equate. So we have minus FGB times 25 times 10 to the power minus 2 is simply equal to minus a half times 0,145 multiplied by 32 squared. And of course, when you compute all of that, you will simply find that the force exerted by the glove on the ball is simply equal to 296.96 newtons. And of course, remember that force was going in that direction, so it was opposite to the direction of motion. So the force exerted by the ball on the glove has to be the same magnitude, which is 296.96 newtons, but of course traveling in the original direction that the ball was moving in.